This meeting is being recorded.
So in yesterday class, we discussed about what is SNMP and how do we manage network devices using SNMP. And we discussed about syslog, and we also discussed about file transfer protocols like TFTP and FTP. So let's do a quick round there. Kanish, can you tell me why do we use SNMP and what is the need of it?
Yes. So basically, it's a management protocol to manage and monitor the network devices. Like if we want to see health of the devices, like we can see it through the SNMP server. Like it's a centralized device to monitor the status of the devices, like health and like which health check. Yeah.
Yes, that is correct. So SNMP is like a centralized server that is managing all the devices, which is used for help and validating the CPU, interface going up and down, like those kind of things can be monitored using the SNMP.
Yes.
Siva, can you tell me what are the different versions of SNMP?
No, sorry.
Is this your first class?
No, I attended yesterday, but I did not go through it all over again.
Okay. Let's Anurag, can you tell me what are the different versions of SNMP?
Yes, sir. So there is SNMP v1, there is SNMP v2c, and then there is SNMP v3. SNMP v1 is obsolete. It is a basic type of the SNMP protocol. SNMP v2c is a more advanced type of SNMP v1, where they improved on error handling. And SNMP v3, I think it has end-to-end encryption.
That is correct. SNMP versions are basically came from throughout the years. They expanded on it. They improved the SNMP. So V1 is basically out of standards. V2 added like an error handling, and also they added passwords to it. And V3 is end-to-end encrypted. Yeah. Okay. Dilip, can you tell me what is syslog and why do we use it?
I heard the class, but I don't know that one syslog. Means a syslog server to access a file to the root cause analysis.
Yeah, that's one use case of it. But syslog is basically a log
device
where you will
like
send all the logs and you will store the logs there.
Yeah, storing the data in a multiple devices. Like it is a critical debugging and the standard protocol also. And it centralizes the logging server and contain the data.
Yeah, that is correct. So there are different logging levels, starting from debugging to all the way to critical and warnings. There are different levels of syslog server, so you can go through the different levels there based on the severity. There is a code for every level of syslog.
Yeah, like the error. You're saying about the error messages and the system events. That's all. That one.
Yes, correct.
Yeah. Okay. Yeah. Security alerts and the information. Yeah. Okay.
Yes. Yes, correct. So Hari Prasad, can you tell me why do we use a file transfer protocol?
Sorry, Ravi, like I just missed last class. Like I did not went through the recording.
Okay, that's fine. What about you, Hari? Other Hari?
Hello, sir. Hello. So actually, this is my first class. I came here through Kevin.
Okay, all right. I think we are halfway through the course, so try to complete the recording so that you can, follow along. But we are halfway done in the course. Let's see. Can you tell me why do we use file transfer protocol?
So like we use it to send the files from one device to another device. we have like different protocols for sending this, like TFTP and FTP and SFTP.
Mhm. What is the difference between them?
FTP is like more advanced than TFTP, like that can send videos also, like large size files, whereas TFTP sends only small files like documents or any other small files.
Yeah, and also TFTP is not secure. FTP is more secure because it adds the password to it, right?
Yes.
Okay, all right, that's about yesterday's class. If you did not attend the yesterday class and if you are new something, you have to go to the recording, otherwise it's tough to follow on the next class. So please try to go through the recording before you join the next class. Try to complete the recordings as much as you can. Every topic is separate from others, so it doesn't mean that you have to learn the previous class. It is not like that, because we cover start to finish on that specific class on that specific topic. So it's not like a continuous that you have to go through each class. You can join anytime, but it's important to cover the old topics. Sometimes I may refer something that you don't know that might be covered in the previous class. So it's important to complete the recordings. Okay, let's start today's class. We're going to discuss today about DHCP. What is DHCP and how do we allocate an IP addresses using the DHCP automatically, and we'll discuss about the DNS. And also, if the time permits, we'll discuss about a little bit more other topics like SSH. We'll see how the time permits for us. Okay, so let's go start. So DHCP is nothing but dynamic host allocation. What does that mean? Means like in a network, instead of we manually configuring the IP addresses, we can automatically allocate the IP address to the network devices using the DHCP protocol, dynamic host configuration protocol. For example, in our network, if I have 4 devices and all of these needs IP address, let's say all of these need IP address like 10.0.0.1, 10.0.0.2, 10.0.0.3, 10.0.0.4. So this is a manual way of adding an IP address to each device. And when we do that, we will create the subnet size and the gateway IP. Gateway IP is nothing but the IP of the router or layer 3 device to go out of the network or to go out of the subnet. Right? We define these conditions. For example, if you had remembered our 10th or 11th class, we did a scenario like having a router on a stick. And we defined one PC, and then we defined PC IP address in our lab. And we defined the gateway. Gateway is nothing but router IP for that VLAN, and we defined subnet size. So that means that we are saying, let's say if you want to reach something on the internet. Okay. Let's say google.com. So the packet from your PC should go all the way to the router, because router is your default gateway. And the router will send that packet outside to the google.com, outside of your internet. But the IP address that we configured here is manual IP. But let's say you have 10,000 systems, 10,000 PCs in your network. Is it feasible to configure IPs for each device? No, it is a manual process. So to avoid that, we will do something like dynamic allocation of the IP addresses using the DHCP server. So let's look into the 4-step process of allocating an IP address. Okay. Any questions till this point? So DHCP server. Your router can also act as your DHCP server. Router can act as DHCP server. So let's say this is the PC. So when you turn on your PC, you can do IP address automatic or dynamic setting in your laptop. Many vendors automatically do it so that you don't even notice that you have the setting enabled. So once you turn on the laptop, your laptop will have a 4-step process. Step 1, step 2, step 3, step 4. So this process is called DORA process. So what is the full form of DORA, guys? Discover, offer, request, acknowledgement. So these are the 4 steps to get an IP address for the DHCP server. So first step, the PC does not know where the DHCP server is, so it will send the discover packet. Can anyone tell me in the class, when the PC does not know where to send the packet to, what kind of packet it will send out? When the PC does not know the actual destination, what table it will look at on its database, and where does it forward the packet to?
MAC table.
No, PC does not look its MAC table.
CAM table.
No, PC does not look into the CAM table. The switch will look into the CAM table, but what will the PC will look in its table?
The default gateway.
Yes, it will do the default gateway, but what is that sending the packet called? I know you came
Broad.
close. Sorry, someone said what?
Broadcast.
Yes, it will broadcast, but before broadcasting, what table it will look at? Broadcast is correct, absolutely correct.
Unicast.
Now,
Oh,
unicast is something that you are doing one-to-one communication.
1-to-1, right? Your broadcast
Yeah.
means it will send into like lot of destinations. We don't know proper destination for that.
Yeah, in this case, I don't know the DHCP server, that's why I'm broadcasting. That is correct. I agree with that. But before doing the broadcast, it will look into one kind of table. What is that?
ARP table.
Address resolution table. Protocol.
Exactly. ARP
ARP.
table.
Yeah.
Bang on. So it will look into the ARP table to see if it know that destination. If it is not there, if it doesn't know where to send the packet to, then it broadcasts, right? So it will send a discover packet, which is the broadcast packet. What is the destination, guys, for the broadcast? Is a broadcast packet. So what will be the MAC address for the broadcast? When it doesn't know the destination, what will be the broadcast MAC address?
IP address.
No. What is the MAC address?
Memory table.
What?
Memory table, like it's a cam.
No, the cam is not there. Cam is on the switch. It will do the all Fs. Remember? That is the MAC address. It sends the packet to when nothing is
Broadcast.
matched, because it's a broadcast packet.
Yes.
So now that broadcast packet with destination all Fs left the PC and went to the default gateway. In this case, let's say this is the router. Okay. You configured the DHCP server on the router by putting the DHCP server configuration on the router. Now the router will respond back that it will offer, I am your DHCP server and I can offer you a IP address. Here is my IP address. Okay, so first packet, the discover packet is broadcast packet because it does not know what is the DHCP server IP. So it sent the broadcast packet with all Fs. So that packet went to the DHCP server and DHCP server responded back with an offer message. Okay, now the PC knows the IP address of the DHCP server, which is the gateway or which is the router IP here. Now, what kind of packet will be this, guys? The third packet, will it be broadcast or will it be unicast?
Unicast.
This will be the unicast packet because server offered its IP address to the PC. PC know what it is talking to. So now this will be a unicast packet. And PC will request IP address. Can you assign me a IP? So acknowledgement, so this is the request packet. And the acknowledgement packet will be DHCP server assigning an IP address. And gateway and subnet size. So that's how the PC will send the discover packet, the server will send the offer packet, the PC will request an IP address, and then the server will be sending the DHCP IP to the PC, and it will also send the lease time. What is lease time? How much time the PC IP address will be activated, the IP address will be up and running. What is the complete amount of lease time the PC can claim that IP? Once the lease time ends, the DHCP server has to request an IP address again. So it also adds the lease time to it. Okay, so DHCP is basically we are having the DHCP dynamic allocation of the IP addresses for the different systems. When we have large number of systems, we will use that. Okay, and in the DHCP, we should also know about configuration of the DHCP. So let's look into the DHCP configuration on the router. How we can configure the DHCP. So on the router, PC is router. So on the router, what you can do, you can go to configure terminal. That is just to go to the configuration mode. You can do IP, DHCP, pool, and define the pool name. In this case, I would say my DHCP IP range. Okay, and I can define network and then define 10.0.0.0, 255, 255, 255.0. What does that mean, guys? So this DHCP server will allocate the IPs in this range to the PCs. So that is what this pool is. So whatever pool we created, whenever the DHCP server PC requests a DHCP IP, the router will pick one of the IP address and will assign that to the PC. So that is what we do there. And then we also define default router and then IP address 10.0.0.1. That will be the gateway IP pointing to PC. And then we can also do specific DNS server if we want. We can also allocate the DNS server to the PC, but that is something that is an extra feature. If the PC wants a DNS server, we can also allocate that, but we'll look into that when we talk about the DNS. But just keep that in mind that the DHCP server can also give the DNS server IP to the PC. What else? Yeah, we can do like check the check using show IP DHCP pool. That will give me the pool configuration that I configured. What is the range of IP addresses that I configured on the router? That is a show command to validate that how I can see it. Okay, so that's pretty much it about DHCP, configuring the pool, configuring the default router, and then validating the DHCP pool. That's how we can do it on the router. Now let's look at the DHCP relay.
I have a doubt.
Okay, go ahead.
Okay, so how does the DHCP server know that the PC is looking for DHCP server? You said it's gonna
The router
broadcast.
now.
How does the DHCP server know that the PC is looking for DHCP?
It sent a discover packet.
No, in the previous in the previous explanation, you said it's gonna send a broadcast packet, right?
Yes, that broadcast packet is a discover packet.
Okay.
It is a type of packet at the layer 2, which is the broadcast, but it is still a discover message.
Okay, so only the DHCP is going to respond, not the other devices.
Yes, correct. Because
Okay.
we are sending a discover packet, only the DHCP server will respond back for the discover message. Correct.
Okay.
Well, you got a good point there. What if a different device responds? You got a very good point. That is why there is a concept called DHCP snooping. Meaning, any other rogue device can send the response for the DHCP request message or offer message. So discover message. To avoid that, we will configure an interface to send only DHCP discover messages. Meaning, let's say this is the router. let's say there are 3 devices connected here. Okay. Let's say this is DHCP server. This is rogue device. This is a PC. Just think about like that. We sent a discover message from the PC to the router. We know that the router is connected to this interface on the DHCP server. That's why we enable DHCP snooping, so that only the discover packet only will be sent to this interface. This will not be sent to other interfaces because there might be a rogue connected. So to avoid that, there is a security feature called DHCP snooping. But this is out of CCNA syllabus. It is more into CCNP. But because you asked a question, how do we know only the DHCP server is responding? We have a security feature called DHCP snooping. Is it clear?
Yes.
Okay. Okay, now let's go back to DHCP relay. Let's consider the topology again. PC, switch, router. Different router. DHCP server. So the DHCP server IP is 10.10.200.10. Okay, the router 10.0.0.1. Now the PC sent the broadcast packet, which is a discover message, to the gateway. But the router is not acting as a DHCP server. The DHCP server is outside of that subnet. Can my broadcast packet leave that subnet, guys? Can my broadcast packet leave outside of my subnet? Monica, can my broadcast packet leave outside of my subnet?
No, sir.
Yeah, my broadcast packet will not leave outside of my subnet because it will be broadcasted only in that specific VLAN or the connected interfaces in that specific broadcast domain. But because I sent a discover packet, it has the only went to this interface with that specific VLAN gateway. So here it reached to 10.0.0.1. But my DHCP server, there is no DHCP server in this zone or in this VLAN or in this subnet. Then we need something called DHCP helper or DHCP relay agent, which both are same, helper or relay agent. So what does this do is, you will create the DHCP relay agent on this specific interface, telling the router to point that discover message to the DHCP server, which is outside of the subnet. So when the discover message, which is a broadcast packet, comes to the router, because does not have any response acting as a DHCP server, or there is no DHCP server in this subnet, we have to tell the router to use the helper or relay agent that to point that request to the specific DHCP server, which will be a unicast packet from now on, because the router will route that packet to the DHCP server. So whenever the DHCP server and the PC, they are not in the same subnet, then the IP allocation will not be possible. In that case, we need a DHCP server or relay agent. Any questions? Okay, let's look into the DHCP relay agent configuration on the router. Okay, what we're gonna do is, let's say this interface is like interface gig 0/0, something like that. So on this, something like that, you will do like IP helper address, 10.10.200.10. That is what you will configure on this specific interface, so that whenever the discover message comes to this interface as a broadcast packet, we're gonna forward that to the DHCP server, which is configured with this IP address. That is how my discover packet will be going to the DHCP server, and the offer message will be sent out and sent back to the PC. The PC will request an IP address, and the server will respond back with the acknowledgement with an IP address. So the concept pretty much same, but in this case, the DHCP server is not in the same subnet as the actual PC. Any questions before I move to the next topic?
Can there be multiple DHCP servers in different subnets?
Yes, there can be multiple DHCP servers. And if there are multiple, you can assign the priorities, 1, 2, 3 priorities. Based on the priority, it will choose whichever, let's say, PC1 is there, router is there, and there is 3 DHCP servers in a cluster. Server 1, server 2, server 3. So the discover packet came in, it went to all the 3 servers. But whichever has the high priority, that server will respond back. So these DHCP servers will have to communicate each other to offer which request to what. And in some cases, you might have multiple PCs wanting different IP addresses from DHCP servers. In this case, you will put this interface in VLAN 1, and for that VLAN, you will forward that to a different DHCP server, and this PC, you can put it in VLAN 2 and forward that request to a different DHCP helper address. So you can separate them using the VLANs if you want to separate your DHCP request and response, or you can make them in a cluster. Clear?
Yes.
Okay. Good questions. Now let's talk about DNS. Have you guys know what is DNS? DNS is domain name system. It will allocate, it will translate name to IP addresses, right? For example, google.com, right? This is just a human readable name, but there should be a conversion of this to an IP address where my PC can communicate. So that's why the domain name system will convert the names to IP addresses. So now let's see how the DNS works. Okay. Let's say I'm having a PC and I want to go to google.com. In the first class, if you have remember, we talked about the OSI stack. In that, we had already gone through some of the steps that we can do to go to google.com, but let's recall that. So in the google.com, whenever I type https google.com, first my browser cache will be checked. Browser cache. To see if the browser can resolve IP address for google.com. Okay, first the browser cache will be checked. If there is no response, from the browser cache, then next thing is to check the host entry file in the laptop. Check the host file in the laptop to see if it can resolve. If not, next is to send the request to the DNS server. In this case, a router can act as a DNS server, your default gateway. Default gateway or router can act as DNS server. You will send a DNS query message. DNS query. If the router can resolve that, it will send the IP address back to the PC. If it is no, then the request will be sent to the root, or let's say external DNS server. If it sends the response back, that is fine. If there is no response back, that external DNS server will talk to root DNS server. Root DNS servers are like 13 DNS servers are there across the globe. Whichever is close to your country, the request will go to that root DNS server. And now let's look into the root DNS subdomains. So the root will have the top level domain and sub level domain and host entry. So root is nothing but the .com, the top level domain is nothing but .com, .uk, .gov, .edu, those kind of domains. So because your request is under the .com, the .com will be going to the sub level. Now the sub level will be mapped to google.com. So that will be mapped to the host entry. Let's say the IP address is mapped to 8.8.8.8, and that 8.8.8.8 will be sent to your PC. So let me show a diagram to make it easy. Let me open my blog. Can you see my screen?
Yes.
Sure.
Okay, so initially the user enters a URL. It will check the local cache, and the DNS will be sent to the local DNS server. If it does not have the response, it will be sent to the root DNS server. the root DNS server will be sending that to the top TLD, the top level DNS server. That will be sending to the authoritative or the host DNS server. That will be sending the IP address back to the DNS server. That will be sending back to your PC, and you will be seeing the response. So that's how the DNS query works. So this is the process. What happens to resolve an IP address? So now let's see. If I do NS lookup and then do google.com. So it says NS lookup, the IP address of the google.com is 142.250.68.142. So when I did that, it checked the cache first, and then it went to the TLD, and it went to the authoritative DNS server, and then it got the response of the IP address. So this is the command you will use to check the IP address to go to the google.com. To check the IP address, you will do NS lookup on your CLI, or you can also do dig. Dig will give you more information. Like for example, you can do dig. Yeah, so the dig also gave me the same IP. This is the question section. I questioned for google.com. The answer section, I got an IP address back with this IP. So you can also use dig, but it depends on what kind of device you are using. Sometimes dig is not supported on Linux, the different OSs like Windows, but the Mac OS or the Linux will support the dig. So that's how the DNS works. Basically, the DNS is getting an IP address. When you enter a URL, you have to resolve an IP address for that URL. That's how the DNS works. You can also read through my blog that I have written in detail, step-by-step process, what happens. Whatever I said today will be written in the blog. You can go through that. I guess you already have my blog credentials. I mean site ID, right? So you can go Google it. You can get step-by-step process there. So that's about DNS. So let's talk about DNS records.
Can you share your blog credentials? Or
It should be on the our channel. It's already there. If not, I can do it again. Let's see. Yeah, I'll put it here in the Zoom chat. Hold on.
Okay.
Which channel it is?
Yeah, I know there are a lot of. But never mind. I'll put it here.
Hey, I'm not in the group. Could you add me to the group?
Yeah, let's not talk about all of that now. Let's complete the class, and we'll talk about all of that later after I stop the recording. Okay, but the group, I mean the site URL is in the channel chat. You guys should be accessing that. Okay. So now let's talk about the DNS records. There are many records, but let's talk about the major ones that we should be focusing on. DNS record types. A record, CNAME record, PTR record, TXT record, mix record. So A record is name to IP mapping. So if I enter google.com, getting an IP address is called A record. CNAME record is name to name mapping. For example, if I have, let's say ravi.com, I can translate that to maybe ravi1.com, and that can be mapped to 8.8.8.8. This is used basically to map one URL to the other URL and then finally resolving to the IP address. This will be done when you are doing some kind of migration or changing the URLs. You will map your CNAME to one URL to the other URL, and then it will map. So name to name mapping is called CNAME record. Now let's talk about PTR record. IP to name mapping. Meaning, if you know the IP address and if you want to know the what is the google.com, I mean what is the host name for it, the PTR record will map the IP to the name. So in the beginning example, the other example, we were looking into the dig, right? So if I do oh, I'm not sharing that screen, so give me 1 second. Let me stop share. Mute share. Okay, so if I do dig google.com, so you see I got a record mapping the IP address. If I know the IP address, dig -x, if I put that, or let's say dig, well, this is something that is used by other CNAME, so let's not get confused. Let's do dig -x 8.8.8.8. You see 8.8.8 is the PTR record that mapped to DNS.google. So when I do the IP address, the mapping to the name is called PTR, but when I do the name, mapping that to the IP address is called A record. So PTR is nothing but reverse mapping. A record is name to IP mapping. Clear, guys? Is it clear?
Yes.
Yes.
Okay. So next is the TXT record. TXT is to add information about your website. Meaning when I do a TXT record for google.com, when I do check the DNS, it will add a text column to add more information about my website. So that is the TXT record. TXT record nothing but it will add the text format that will contain information about your domain. That is the TXT record. And the last one is MX record. MX record is like mail record. So when you looked up for mail DNS servers, they will route your emails to the correct mail servers. So this is something that is out of CCNA scope, but mail record will, when you send the DNS request for a mail IP, the mail MX record will point that to the specific mail server. Just like DNS pointing to the one IP, the MX record will point to the right mail server. Let's say you have Google, you went to your Gmail and there are multiple Gmails. I mean, there are multiple Gmail servers, right? So the MX record will direct email to the mail server. So you will, from here, it will do the mail to the specific email server. Whichever is closer or whichever is high priority or whichever is the translation, it will send that record to the mail to the specific DNS server. Okay, is that clear? Let's say, for an example, you have .ravi mail.com. Okay, so someone is trying to send me to this email, they want to send the mail. So in their DNS, they will point that mail to this mail server with an MX record. So it is a record in the DNS where you can configure the record types as MX that will deliver the email to my address, because this guy is typing send an email to, for example, ravimail.com. When they type that, that mail record will be pointed to my website, and I am getting that mail because my mail is getting resolved to the specific MX record type with an IP address. So basically converting mails is in the DNS is called the MX record. So again, name to IP mapping is a record, CNAME, name to name mapping is CNAME, IP to name is PTR, adding information is TXT. MX record is having a mail record so that the mails can also be reached correctly to your email address with the DNS resolution in the mail entry. Okay, any questions there? Let's start with SSH. What is SSH, guys? Secure shell, right? So SSH is nothing but creating a socket from your PC to the specific network device or a network, a server or a PC, so that you can safely log in. So let's say I'm on this PC. I want to log into a specific router. So what I'm going to do is I want to log into this device. But when I log in, no one should see my username or password in the middle. So what I'm going to do is I'm going to create a secure channel between my PC to the router so that it will be encrypted end to end. And my data is securely sent over the channel. So that is nothing but SSH. SSH gives you like secure way to access from my computer to the network device. So you can, let's say your router is on a Google, or if your device is somewhere, but you still want to access that, you will use SSH to communicate with your router. But you still need the network access. Like you should be able to reach that. The ping should be working. The network connectivity should be there. But after that, the PC should be able to access to this router by having a secure connection. Okay, so in the real time, let's say I have a server. That is server name. It could be any name. So here I went to that host. That my password is already saved there. So let me log into a different device. Okay. That's my username. Let me go to one of the switch. So I entered my username Arkiran and entered the switch name. Now it's asking me for the password. I entered my password. Now it logged me in. So what did I do? I did the SSH with the username and the switch name, and I entered my password. So no one in the middle, even though they capture the data, they will not be able to see my username or password because it is all end-to-end encrypted. That is the reason why we use SSH to log into the devices. So if you have a device and if you wanted to access remotely of the device, you can use protocols like SSH to log in to the device securely. That is what we will use SSH for. So if I don't have the SSH. I can have other mechanisms. For example, I can use like a console port, meaning I can manually go to the switch. I can manually go to the router and I can plug into the console port with a cable. But what if I am remote? If I am remote, I can do SSH to the device securely over the internet to talk to this device. I sitting in my home, if my router is somewhere, let's say it's in maybe Nevada, I can still remotely log into the device using the SSH protocol. So no one in the middle on the internet can look into my data. It is protected and it is encrypted. That's why it's SSH protocol. Any questions there? No questions? Okay, let's look into the SSH handshake to understand a little bit more about the communication between them. So, first, the PC will send SYN packet, SYN ACK, and then ACK. What is this, guys? SYN ACK ACK. What is this?
Synchronous packet, synchronous packet, and acknowledged packet.
This is TCP, right? So this is a secure communication. PC will send the SYN packet, server responds back with the SYN ACK, and the PC will send the ACK back. So the TCP three-way handshake is completed. This is secure connection, right? So that is done. After that, what it will do? The SSH message, SSH request message will be sent, meaning like, hey, I wanted to make a connection. So that will be a SSH message. That I wanted to make a SSH connection. That is called key initialization, key init message. The server responds back saying that, okay, I got your message. Here is my key. Enter your password. Okay, so now I'll enter my password on my PC. It asks me for the password. I'll enter the password. Now, when I enter the password, the router will check back in its AD, which is the active directory where my password is saved. So the router will check the AD whether I entered the right password or not. If I entered the right password, the key exchange will be completed. And then the secure channel is formed. There is also negotiation like ciphers. Cipher is nothing but an algorithm to encrypt the data. So whatever the ciphers my PC is using, that has to be negotiated with the router ciphers. If there is a mismatch, the secure channel will not form. Ciphers are something that is like an house strength of your security is. So ciphers is nothing but they will put your password in a different algorithm so that no one can break it. It is like an encryption technique. So PC and the server has to negotiate with that cipher. And then once I enter my password, the password will be checked on the AD. If it's matching, this SSH channel will form, and now I can log into the device. That's how the SSH handshake will work. First the TCP handshake, after that the SSH key initial messages, they will both will be exchanged. After that, the password will be validated, and then it will get the access to the PC, will can access the router. Any questions? Okay, let's summarize today's class. In the beginning, we discussed about DHCP and DHCP relay, and then we moved to DNS. In DNS, we discussed about getting an IP address for the DHCP DNS request, and we discussed about DNS record types, and we discussed about SSH protocol. What is the use case of the SSH protocol? That's what we discussed today. So now let's do a round. Mahit, can you tell me what are the 4 stages of the DHCP process?
Root DNS. So top level, sub level, host.
No, I'm talking about the DHCP IP allocation process. What are the 4 steps?
A recorder, serial recorder, PTR recorder. Yes, sir, you are asking.
No. Shiva, can you answer that? What are the 4 stages of DHCP allocation? IP address
Yeah,
allocation.
it's called the DORA. So it's a discover, offer, request and acknowledgement. So basically, we send out discover packets first, and then the DHCP sends the offer packet back, saying that this is my IP address, and the request pack would be sent back by the PC to the DHCP server asking for an IP, and DHCP server will then assign an IP to the PC.
Okay. So, Rangachari, can you tell me if the DHCP server is in the not in the same subnet, how can I get an IP address?
We use snooping.
Well, snooping is protecting the DHCP server, but in this case, I don't want to protect it. I wanted to get an IP address, even if my server is not in the same subnet.
Okay, you're asking me what type of packets does it use?
No. How can I get an IP address for my PC when my DHCP server is not in the same subnet of my discover packet? Anurag, can you answer that?
Using DHCP relay.
Yeah, we can use DHCP helper or DHCP relay, so that when my request sends in, the broadcast packet will go to the router, and the router will use the relay agent or the helper address to point that request to the DHCP server outside of the subnet. So the answer is DHCP server, helper or relay agent. Okay, Dilip, can you tell me how does the DNS works when I type google.com?
It will check the host file in the laptop so that we can resolve it, or browsing the cache to see the address.
Okay.
It is basically a translate name to IP address. Is it correct?
Okay, correct.
Yeah, okay.
After that, so I check the browser cache. I check the local DNS.
The host file in the laptop, and we can resolve it.
Yeah, if it's not there, what will be the next action?
If it is not there,
then it will go to the
domains.
Yeah, it will go to the local DNS server. It will check there. If it's not there, it will go to the external DNS server. Then it will point to the top level domain. It will have the sub level domains like .com, .edu, .gov,
and .gov. It all comes under the top level.
Yeah.
And
And
The
from there,
sub-level,
it will go to
sub-level
the
mapping. You said that sub-level mapping to the google.com, and it goes to the host entry.
Yeah. And then the host entry will be having the IP address that will be sent to your PC. That's how the
Yeah.
DNS works. Yep. So, Hari Prasad, can you tell me what if I wanted to convert IP to name in the reverse direction? What record I can use?
PTR record
Yep, that is correct.
proportional to a record, right?
Yeah, it is opposite to the A record. A record will be doing name to IP mapping. The PTR record will map the IP address to the name in the reverse direction. Okay.
Yeah.
Hari, can you tell me why do I use a TXT record?
It's to add information about your website.
Yeah, to add information about my domain, I can put a TXT record to give more details. That is correct. Okay. Maunika, can you tell me why do I need SSH?
Creating a socket between different networks or a specific network.
Yeah, I
And
can
it is-
create a secure connection from
Yeah,
one
it is a
device to the
secure
other
way to
device.
access and communicate between the networks.
Yeah, so if I wanted to secure my username and password, and if I want to log in, I can create a secure connection, like a secure tunnel by negotiation between the devices, and then I can log into the device. That is why I need SSH.
Yes.
That is good. So that's all for today, guys. We discussed about those topics like DHCP, DHCP relay, DNS, and types of DNS records and SSH. Tomorrow we're going to discuss about other services. So for now, that's it. If you have any questions, you can ask, or you're free to drop. Let me stop the recording first, and then I'll let you. I'll open the floor.